I just finished unmounting one of the multi-section electrolytic can capacitors, and in case any of you are curious as to how it tested, I fired up my solar capacitor tester. This is a 40 microfarad section rated for 450 volts. So let's check for leakage first. It doesn't look too bad, alright? It's starting to form up a little bit. Can almost get it up to 400 volts. And no leakage down to 3. However, if you ever used one of these before, you recognize there's a little issue. There's two sections on that neon bulb. The left side glows as you're going up through the voltages, and the right side should glow as you go down. It's a little glimmer when I get down to 0, but nowhere near as bright as it should be if it was a really good cap. To further illustrate that, let's try to measure the capacitance. Nothing. So I'm going through this. We should get an eye open somewhere right around in here. This goes up to 70 microfarads. 40 is right about there. Nothing. And experience tells me that even if I can get this so I can go all the way up to 400 or 500 and there's no leakage, it's not a good cap. It's dried out. There's very little capacitance left. I'll show you what a new one tests like. Dried out, or at least lost its effectiveness. The electrolytes they use, in both new and old, things haven't changed all that much. They break down. They chemically break down. Temperature accelerates the process. It's not just a matter of drying out. It's chemically it deteriorates. You can go to the capacitors manufacturers' websites, especially for like Nichicon, Panasonic, and check it out. And they give you a formula for capacitor life. But eventually they all crap out. So get this one charged up and notice much brighter. And as I go down through the steps, we'll get a flash on the other side as well. And it lasts much longer when I get down to 0. It's discharging. And when I go to test it, yeah, we get a definite eye open. So, no sense in my mind in messing around with these old caps at all. You got a TV from the 70s, 80s, maybe into the 60s, sure, but once you get into the early 50s, and for sure the 40s and 30s, don't even waste your time. I used a mini hacksaw to cut open the can. Very easy to do. It's soft aluminum. Here's what the insides look like. I left about 3/4 of an inch at the base here with the thought I can snap it back on to the mount just like the one above it. So I'll pull this junk out, drill some holes, mount the new caps in there, and then snap it back into place. Alternately, I could remove these, drill out the rivets, and mount some terminal strips down here and mount the caps. It's 4 in that guy, and I think 3, maybe 4 in this guy. I started unrolling the cap and check that out. This looked like a bunch of possible punctures there where the voltage exceeded the dielectric strength. Definitely would not want to be using this cap. Here are the new capacitors mounted in place. This was made easy by the use of the skinny Nichicon PZ series caps. They are long and skinny as opposed to more commonly available short and squat capacitors. If I'd used these, there's no way I could have fit 4 inside of that old can. I would have had to run some extension wires out. So all 4 snugly fit in there. Wires, holes were drilled and the leads were run through to the lugs, all safe and secure. And I was going to leave it like this, and it occurred to me, as a courtesy to anyone who may work on this set in the future, I should put this top back on because it's got the legend of which symbols for each lugs are what and what the original value was. Yeah, they could read the values off of these caps, but they aren't quite the same as the original. Like this is a 47 microfarad at 450 volt. Whereas the original spec was 40 microfarad at 450 volt. 40s are no longer commonly available. 47s are, so that's why I use them. So, got that wired back in. I've got this can to do, and then I want to get these two guys. Now notice they have resistors across each of them, and they're actually connected in series. That was done to increase the voltage rating. That is used on the vertical output tube, and it's going to the boost voltage, which is 500 and so volts. Commonly, you can only get electrolytics up to 450. So what they did is they connected two caps in series, which effectively you can add up the voltage ratings if the capacitors are the same value and the leakage current is about the same. So one thing you can do to ensure that the voltage across them divides evenly is to put these external resistors, because there's some leakage current through the caps, and if the leakage current isn't equal, you'll get more voltage across one cap than the other, and you may very well exceed that 300 volt rating. By putting external resistors that are roughly 10 times or more current going through them than the leakage current in the cap, these resistors are going to dominate the situation and force that voltage to be divided evenly. So they use 270. That's about typical. Typically, you'd see between 100 and 330K, somewhere in there. 20 microfarad, 300 volts. On the downside of this is you lose capacitance. So in this case, whether they're the same, you're basically doubling the voltage rating, but you lose half the capacitance. So this will be equivalent to basically a 10 microfarad 600 volt cap. I say roughly because you don't want to go right up to the limit. Let's call it a 500 volt cap at 10 microfarad. So if I did have a 10 microfarad, say 600 volt cap, I could put that in here and take both of these out and forget about the resistors. But I don't want to tinker with their original design, so I'll dig up two caps and test these resistors. I think to play it safe, I'm just going to replace them regardless, because if these resistors drift off value, you're definitely going to get uneven voltage division and exceed the ratings on one of the caps. And I think I'll go with 400 or 450 volt 22 microfarad caps. So in other words, I'm going to exceed their original design to really ensure that the circuit will hold up for a long time. Here are the new series wired capacitors in place. It's getting harder and harder to find name brand axial electrolytics, but I did manage to dig up some 22 microfarad 350 volt Illinois capacitor caps. And there are the new bleeder resistors, 270K 2 watt. And I finished restuffing this cap and wired it back in, new power resistors. However, when I got to these, I wasn't quite sure what to do because these are not shown in the SAMs, they're not shown on the schematic. You go from this point to the can here, which is ground, and I believe this is a 90 volt rail. I'm inclined to wire them back in because it looks like an original joint there, and they sure look like these resistors over here, which do appear to be stock and are shown on the schematic. In fact, as I look at them more closely, I mean, the stripes look exactly the same to me, like they're from the same manufacturing batch. So I'm inclined to think that it is original, just a production change. So I got to wire these back in. I want to wire that back in, or replace it actually, because it's drifted out of tolerance. And I clipped one or two caps out of the way while working, so I could get at things more readily. So I got to replace that guy, and that might be it. And then I want to try a power-up, even though I haven't replaced everything yet. There's another interesting combination of resistors. I don't know if they did this because of part shortages, because the rest of it seems to be pretty well the same, whereas, for example, the Mercury set I worked on recently, there were 2 or 3 different types of caps in there, And I've worked on some Admiral sets from the early 50s where there were resistors from West Germany or Japan. But these all appear to be the same type of carbon comps used throughout. All the caps are the same type used throughout, except for the more modern replacements here and there, where clearly some repairs have been done. So I don't know if they did that because they had trouble sourcing parts, or the combination was an odd vol value, so what, 6.8, 6.8. 15K is pretty close, and that's a pretty readily available value. Or was it to increase the wattage, or was it to increase the voltage handling capabilities? Because resistors do have a voltage rating, although by the time you get up to 2 watt resistors, they can handle more voltage than I'm pretty sure there is used in any circuits in this set. Like example here, 90 volt, even a half watt resistor can, they're good for usually, I think, 300 volts, 350 volts, so I really don't think it's for voltage. Like you see in some electrostatic sets, there's a long chain of resistors. That's because it's running on thousands of volts, not hundreds of volts. Anyway, I do want to tie up a few loose ends and try powering this up. But for sure I want to go through and replace the rest of these caps. I mean, some of them look pretty nasty, but I'm hoping to eke out some sound, see if the tuner's working, and see if we can get a little high voltage going with the old parts still in there. Alright, I tidied things up and I'm getting ready to do a power-up test. Plug cheater cord in. I've got my voltmeter on main B+. I believe it should be about 310 volts. So let's see what happens. Reacts on, and set is on. It's kind of hard to see that meter with the lights. That's better. Oh, okay. Well, something was very, very wrong under here. Something right down in here went up immediately, but I don't know what. I can figure maybe it's one of the caps. It's not so visible. Oh yeah, okay, I see it now. It's cap on the back side here. Let's see. And if I had to guess, it's because I made a mistake on this guy. Because in that can, there's 4 caps. 3 of them are rated for 450 volts, and the voltage didn't get that high to blow those out. But the 4th cap is only rated for 50 volts, 100 microfarad. I'm betting I wired something up wrong there, and that put way too much voltage on that cap. And kablooey. I'll pop it out of there so we can get a better look at it. Yep, there it is. A little small cap there. Popped its top. So I'll double check my wiring. There's also a possibility that the wiring is entirely fine, and that the problem lies with whatever that's connected to, which has a problem because maybe there's something shorted out. So it's that cap right there, I do believe. 100 microfarad on the cathode of the 6S4 output tube, and they said there should be only 22 volts on that. So it should be simple enough to trace out. There's nothing else going to that, so I'll see what's going to pin 2 of the horizontal output tube, which I believe is that guy up there. And hopefully I just have it switched with the wrong lug. Oh, I have to get up in there and make sure I got the right wire and trace it down. I'm pretty sure it's this yellow wire going right down here, which, yeah, looks like I got things maybe a little turned around. Alright, well, I'll double check all that stuff, and hopefully it's just a matter of switching wires between 2 lugs. Well, it turned out that my wiring was correct. What wasn't correct is the internal capacitors. I had flip-flopped the 100 microfarad and one of the 40 microfarad. So I was able to salvage the 40 and unsolder the leads and put it back where, or put it where it should be. And I replaced the 100. Here's the one that failed. Alright, now I'm ready to try that power up again. So it's off. Variac on. And here we go. So holding better this time. Some noise coming out of the speaker. You can hear some whining coming from the high voltage circuit. I'm not really getting a sense the tuner's doing its thing there. Voltage is holding pretty steady. I guess that would be 6 right there. I'm hoping to get a little reception on that. Alright, well, this thing's voltage seems to be holding steady. I'm going to check a few other points. Like this guy right here. Oh, wrong side. I meant over here. That's where those 2 resistors are going that I was a little... Okay. There's a 115 volt bus and there's a 90 volt bus. I'm not sure which that is, but either way, it's pretty close. If it's 115, it's dead on. If it's 90, it's off a bit, but it's alright. Let's check over here. 40, 23. The voltages seem to be okay. And that's that cap that had failed earlier. That says should be 22 volts on the service info, but I got more like 45, and I got a 63 volt cap in there, so I'm not concerned about that failing. And let's check out these series caps. That's a good sign. 220 on one side, and yeah. So the voltage divider is doing its job well, and that means the flyback has to be running because we're stealing power from that. Now I don't have the test CRT installed, but if I bring this probe near that cap, yeah, I got some high voltage. Very healthy. 16,000 volts, cool. Not sure it's unloaded, but I think that's about what it's supposed to be. Yeah, I think it's a little blurry. Yeah, it says 16 kilovolts on there. Let's see if the SAMS is any better info. It says 15. Alright. So, so the power supply seems to be working okay. We got high voltage, that's fantastic, but seems to be no reception and no sound. So up through here is the IF, and that's audio output. And I've already recapped that area, but not completely. I have some horrible looking caps in here. I think this one's actually getting a bit warm because the wax has softened on it. So how about I get rid of these guys. This is a sound IF in here, and this would be the cap on the ratio detector, I do believe. Yes, the 668 there. That looks like a 5 microfarad cap. 47K across it, yep, right there. So if that cap's bad, that'll kill your sound, and these could also cause some problems. Ceramic caps, I'm pretty sure, are going to be fine, so really this whole IF I don't need to worry about. which is cool. Hopefully, I won't really have to touch it at all. And yeah, this set does have inner carrier, so the video and audio share this common IF, so I'm pretty sure all this is good. Could be a bad tube in the tuner. I know I haven't tested any of the tubes, and I get advice, why don't you test the tubes first? Well, I kind of like to keep things a little more interesting, and I'll test the tubes later. I want to see if I get to work with the original tubes. Also, I find it curious that quite often sets will work with all the original tubes in there, even though they may be weak or have some mild shorts in them. So yeah, I'll get this area recapped and see if that improves things. Alright, replaced those caps in the audio circuit. Let's see if it made any difference. Definitely hear some crackling now as I turn the volume control. Still not much going on with the tuner though. Expect to at the very least hear static. And hear some change as I go through that to the channels. Well, I'm pretty sure this is, yeah, that's the control off the volume. We'll wire up the volume control right there. So audio amp speaker is working, and so the problem has to be further back. Well, one thing I can do is check the voltages going into the tuner, make sure they're good, and then I think it's time to maybe let me test a few of these tubes. It's pretty easy to check the tuner. There are 4 wires going to it, A, B, C, D, and on the schematic here they're labeled. A goes through a couple power resistors to 310 volt bus, B goes to the plus 150 volt bus, C is filament, and D is AGC. All those seem to be okay. And then I realized if I didn't have the volume cranked up all the way, if I do actually get what appears to be static. So I'm going to fire up, I think, a test pattern generator and feed a signal in. Maybe if I feed a stronger signal than I would pick up over the air, I'll be able to get something coming through. Alrighty, let's see if this makes any difference. We've got the set on channel 3. Kilohertz tone. No, not getting anything. Got the contrast up all the way. I kind of, sort of hear something there, but not really. I'm just trying another channel just for the heck of it. Crank the RF level all the way up. Alright, something's not getting through somewhere. Hopefully it's a tube and not an open IF transformer. I checked all the tubes in the tuner and the IF and the audio, and none of them were really bad. There was a very mild plate short in one of the 6AU6s. I replaced it, but I don't think it's going to make much difference. Also notice there was a 6X8 in the tuner, whereas it designates 6U8. I think they're pretty darn interchangeable when I put in a 6U8 anyways. So let's see if that makes any difference. Now I'm back to kind of not really getting any hiss even out of the tuner. Now there is one other definite possibility. So if it's not the tubes, caps have been replaced. I still haven't checked all the resistors. Certainly some of those could be bad. Could still be an open IF, but there's another possibility, which is the detector diode, early germanium type, and it's inside one of the IF cans. I believe it's this guy right here. Now, I'm inclined to try popping a test picture tube because the detector diode would affect both the video and the audio. If I put in a test picture tube and I see that I've got video, then pretty good indication it's not the detector diode, it's something else. So let's see if I can figure out how to get this little CRT up in there and hooked up. I was able to get the CRT seated in there reasonably securely. I got the set fired up, but I'm not really seeing anything yet, so try adjusting some of the controls on the front here. I got a horizontal and vertical hold, and there's the brightness control. Well, we certainly have a circle. Back off. There's a contrast control. It's definitely doing something. So I've got test pattern generator hooked up. What kind of pattern have I got? Let's see, I'm on channel 4 and crosshatch, I think. But there's something arcing like down inside the high voltage box, since it's causing this interference. Pretty sure the channel that you select is the one that's most to vertical. That's what I've been going with here. So yeah, we're not getting much luck with receiving anything. But hey, we've got really solid high voltage, and we've got horizontal and vertical sweep, so that's all very, very good stuff. And since there really was no video, no sync, now I'm really starting to suspect a detector diode. So to go about checking that, there's a nut or a screw on either side of this on the bottom. I've taken those off. I think I can pull this top off. Take a look at it. Actually, before I go diving into this can, let's take a little more methodical approach to it by doing some signal injection. We take a look at the schematic. Let's start working our way back from the picture tube. Particular video output amp and a video amp. And there's a detector diode. Let's try injecting a signal right about here. And conveniently, they even tell us that at this point, it looks like it says 1 volt peak to peak. Go into the grid of the 6AU6 video amp. Well, it just so happens that we've got video out, 1 volt into 75 ohms. Now it's an RCA connector there. I got a little RCA to BNC adapter. Going to my cable. I got a 75 ohm terminating resistor there. And this is that 6AU6 tube. Not so easy to inject a signal from the top side, unless you got one of these, which is socket extenders. It's got little tabs here for each of the tube pins, and there's pin 1. And often you can just inject your signal directly to it, but it doesn't hurt to use a capacitor to block any DC potential there. From there, getting back into your signal generator, I just grabbed a 0.22 microfarad, 0.1, anything fairly large would work fine. So let's see what that does for us. So at this point, if it goes through, that will feed the sync circuits, the horizontal and vertical sync down in here, and it will drive the CRT. So perhaps we'll get an image on here. Hey, look at that. I'm using a crosshatch pattern right now. Let's see if we can get to sync. No, but that doesn't really matter. The point is, no, the video amp is good. I might also have the wrong polarity, but hey, it's kind of syncing. It's kind of an image. So the problem could very well be that detector diode. Just going through a few different patterns. Alright, so now what? Well, we know that things are pretty much okay from here on. And we know that the sync separator and the oscillators and the yoke all seem to be good, which is fantastic. Well, what about injecting a signal back here? Well, this uses a 44 megahertz IF, which I think, yeah, this can do that. So if instead I take the output from here, instead of RF, I switch to IF mode. Let's see if I can inject a signal going further back, somewhere in here. And if that works, then I know the problem is even further back. If it doesn't get a signal through, then it could very well be that diode that's the problem, after all.